Bismillah. Here is assignment 4, which is simple mesh by Dealii. This is the first step, actually step 1 of Dealii. And this is a course of advanced numerical analysis. In this video, I will explain the explanation of the code for step 1 in Dealii and how to modify the code. And the simple mesh explanation documentation of Dealii in its website. So this is one of the results of the step 1, and this is another one. So we'll show how to read through the documentation and how meshes are generated by C++ code and how to run them in Linux. So this video is actually interpretation of this reference. Actually here the triangulation is very important because it's actually expresses the collection of cells in finite element analysis and also other phenomena. And the C++ language that is used in this case has many collection of classes, which has a lot of advantages here. And I will run the program in the Linux and visualize it. Also, what about the Dealii? Dealii is actually the open source media where from the website I will show where the documentations are available and how to get that documentation, which is very handy. So let's get to the website. Dealii.org. Okay, so if we go here, then you can see it's a C++ software library supporting the finite element course. Well, it has an open community for users, so it's very handy and it's very convenient. And yeah, there are a lot of course here, you can collect that easily, and there are various type of version, you can see that, and you can get a tutorial here also. Yeah, if I go to the tutorial here, there are a lot of hyperlinks, so we can get a lot of information from that website. And yeah, in the tutorial you can see various steps and yeah, the flowchart, how the finite elements are working, and these are the steps that has been inherently in this package. So if I will come here later. Also I will show the documentation. If I go to the back, then there will be documentation. Yeah, there are a lot of versions here, and for the master version you can get the documentation of the master version. You can go to the tutorial from here also. What about the manual? So yeah, in the manual you can be introduce the classes of the C++ here, such for the triangulation that was mentioned in the first minutes of this video. And actually the triangulations are a collection of cells, and they are lower dimensional boundary objects, and other description of triangulation and where it can be applicable, and the faces, lines, and etc. Also the manifolds, finite element, and degree of freedom handler. Actually, in the previous video I have discussed how the finite element does work in a flowchart or in a stepwise way. So this is one of the steps, and if I click here, then we will go through the details of the finite element analysis. These are the classes, various types of classes, which and we can go to the classes which we are interested to. Well, yeah. Here is one of the example how the grand scheme of things and the pieces of module interact with the variety of the parts of the library. And this, yeah, with the triangulation and finite elements, which evaluates the degree of freedom, and also mapping and quadrature. It defines the finite element values. So it goes to the last of the solution, and we can get the output. So there are a lot of hyperlinks. If you click here, the linear systems, you will get the total description about that. The vector classes, vector memory management, etc. Okay, so get to that tutorial. Yes. So for the first, here you can see this one, the tutorial 1. There are a lot of block codes here and how we can run it. There is a simple description of the command, what we will insert into the command of the Linux terminal, and they have also declared about the functions of the include and also the helper function, how the first mesh is created. The explanation is described here step by step also, and last of all you can get the plain code. These are the results of that code, and just a minute. I'm looking for the int main, which is stated in the last of the code here. So in the int main there are two grids, the first grid and the second grid. So there should be two sections in the code. If we hover over on the upper side, we will get the block codes here and the explanation too, and these are the suggestions for the extension. And this is basically what I was looking for. These are the plain codes, which is summarized from the upper parts. Now I will explain the code, how these codes are creating the meshes. These codes are C++ that I have mentioned to you before, and first come first. There, this total code is divided into mainly three parts. First part is the top one, second part is the middle one, and last part is the bottom part. So this bottom part is actually the main function. And we can get, there would be two solutions here. And top of the function we can get the helper function. Okay. And most convenient option is here that these functions and classes are hyperlinked. So if you click it here, you can go to that site and get the classes or how the namespace is created. If I want to know about say for example, if I want to know about the triangulation implementation, then I can get all the information from here. However, I will briefly explain the code here. So first of all, in the top of the bird, the helper function is defined here, this one, and then there is a it called the helper other helper function, and then it called the very high functions that call the other functions, and last of all the main function. However, it's all that are related to meshes. Okay. So first of all, in the triangulation, so you can see that first of all this is the first grid. So first portion of the code is about first grid, and the second one is for second grid, and this is for the second grid's output, and this is the output of the first grid. The output of the first grid is written like that. The file is the svg file, and now that first of all the triangulation here. So it's clear that after triangulation there is a 2 in the angled bracket. Okay. So what is that? Actually, triangulation, we know that the collection of cells in the meshes. So the number in the angle bracket is the base dimension here. If this is 2, here it is 2, so it's for the square. If this is 3, then it would be for boxes. If it's in the interval of 0 to 1, then it would be in the triangulation of 1. So if I click it here, you can see that this description is also described here. Okay. Now we will get to the grid generator. Yeah. So this grid generator actually its work is to generate the mesh, and here the class is used in that hypercube triangulation. Hypercube square is for 2D, and if it's for if it's cube, then it's for 3D. If it's in the interval, then it's for just 1D, just like the triangulations among the two between the two brackets. So after that, you can see that triangulation refine global 4. Well, this is very important. So depending on this number is 4, we split every square and it was disturbing. Well, we split every square or every quadrilateral into 4 child cells in 3D. We are talking about the triangulation refined global 4. Actually, uh, we split every square or every quadrilateral into 4 child cells in 3D. It would be into 8 subcubes, and so if we do this once, we end up with 4 cells. If we do it twice, we end up with 16 cells. And so on the 4, so 4 times means we get 256 cells. And after discretization into form, a mesh of the unit square will be generated here according to this line. Well, after that, this is the output, which is in the file stream. The file type is .svg, which is updated here. Previously it was .eps, which is quite old version. And for the grid out, this and this one, there are some difference because all the classes are in the capital form and all the variables are in the small form in the deal2, so is very convenient to figure it them. So this actually outputs a mesh into file, so we can get the mesh into a file by this command. Okay, so I'll just briefly describe the second one too. So this is the picture of first one, and this is the picture of the second one. And you can see that this picture in this mesh, this is actually divided into 5 sections, 1 2 3 4 5 sections, and the mesh is distributed adaptively. Okay, so how it was adaptively distributed? Well, if you go to the document, then this is the second grade one. The argument, there are some argument list for every classes. However, we will first go to the triangulation. This is triangulation bracket 2, that means this is for the 2 dimensions, and we will go to the here considerable inner radius, the center. Here the center of the mesh is defined here. So how we can anticipate that this is a center? So if we go to the lower, this is the hypershell. Okay, if we go to the hypershell, if we go to the hypershell, then we can get the documentation of the hypershell here. You can see that. So this is the argument list here for the hypershell. the argument list of the hypercube is here, and the list is a triangulation, a point in dim dimension here, dim dimension. And also for 2D of course is just an annulus. So yeah, for 2D it would be annulus, and for 3D it would be like that. If we go to the lower one, there are a lot of examples with the help of various classes, but I am looking for this one here. Our our code defines like this. So there is a spherical manifold beneath it, and we can get this type of shape if we insert the hypershell. Alright, and then the triangulation center. Well, here in the triangulation center there is the center, this is the triangulation, the center, inner radius, outer radius, and this number is a number of quadrilaterals. So with that number the mesh is dependent. Okay, so where we can get the center, inner radius, and outer radius, I will recap that after defining the hypershell we will define the center and the radius, and this center and radius was declared here. The center is 1 0, that is x coordinate and y coordinate, and the inner and outer radius are depicted here. Well, then it goes to the for loop, for nested for loop, and you can see that for active, this is quite important, active cell iterators, the triangulation is not just a collection of cells, but it is actually also a collection of vertices. For example, collection of faces are or the interfaces between two cells. So in 2D, or for example maybe the faces are line segments in 3D faces between cells and quadrilaterals. So the triangulation also has a type that is called the iterator, but it is called face iterator. Okay, so then we'll go just to this portion. Well, that when the triangulation are described with the execute coarsening and refinement, then it takes all the cells that are marked for refinement and replaces them by the child cells. It also takes all the cells that are marked for coarsening, and if all the children of the cell are marked for coarsening, and it going to throw away the children and go back to the original cell. Okay, then I will show the demonstration how to run this code. Thank you. Now we will figure out how to run the code in the Linux, how to run the C++ code in the Linux, which is one of the examples in Dealii package. So this is my Linux setup. If I go here, the example, there are almost 70 examples. So I will run this one. So this is the basically the code. If I check it, then this is what I had discussed about previously, and these are the comments for well understanding. Very convenient, I guess. And this is the CMake lists for running. So C is for CMake, and these are the documents where you can see the results. The results will be right like that. Okay, so since I will change the um, source code to observe what are the changes, so I will make a copy here and paste here. I'll rename it like step 1, just modify 1. Yep. So rename it. So where is the modify? This is the modify 1. Okay, let's run the first one. So I can just turn on a turn on a terminal anywhere and copy this directory for change directory, but I like to open the terminal here, so I don't need to change the directory. So in this case we'll cmake it, cmake space dot enter. It has created these files, the cmake install, the cmake for running, and cmake catch.txt and the make file. So since there is a make file, so I will make it make. It may take some time depending on the machine that we are using. So in that time we may browse the cmake folder. So in that cmake folder we can see that some types of features are here, or cmake file 2 and others files that we are not concerned about. So I think the make has been completed almost. So after completing we will run it. Now it's completed, so now I will run it. How can we run it? Just dot slash the file name step 1 and just press it. Now we can see that the svg file, this is for the first grade and this is for the second grade. So there are 5 layers of this mesh, 1 2 3 4 5, and the mesh are adaptive. You can see that. Well, for the first one I guess there are 256 meshes, which is very simple. So let's make some change in the code, just changing the code into the variables, or yeah, we can change here. If we change it like 3, then we need to change also the boundary conditions and others like that. So in this tutorial, in this video I will just change the parameters. Like if we just write here 2, then it should be like it wouldn't be 256, it should be 16. Let's see, and I have to save it. I have saved that. And what about changing the center? Let's not change the center, rather change the radius here and change the outer radius to not 4, and I would like to change the meshes. Here are the 10 meshes, so I like to change it like 20 meshes. And what about here? There are maybe 5, so how about 10? So I have the step. I would like to change it up to 10. Let's see what happens. So I have saved that, and let's go for run. Open a terminal here, just type cmake. Yeah, you can also check the files, how many files are there, by checking ls. So yeah, since there is a make file, so we can make it, make. It is almost finished. Now let's see what happens. We will run it here, dot slash step, not like that. The file name is modify1. I think I have made some mistake. Modify1. So the problem is I need to change the file of the code. So since I haven't changed the file of the code, I need to run like the name of the code here. Let's run it. So first one has been run. Here you can see that 1 2 3 4 5 1 2 3 4. So there are 16 meshes since we had set 2 refine, so we have got 16 meshes. How about the grid 2? It has completed. Let's see what happened here. Yeah, it's so dense here, so it hardly can be detected. 1 2 3 4, maybe 5 6, something like that. And there you have you can see that the meshes are adapted a lot here. Okay, thank you.